Like I'm just confused. Like you assume the left, but then like you have the deduction goal and you have the right. Like why do you have like the left and right side, like in your proof?
Where? What?
The deduction, then you assume the left hand side.
Yep.
Then you have deduction goal, and then you have like the right hand side. But I thought like don't you only assume the right hand side? So, like why are you putting? I mean, don't you only assume the left? So why just the right?
All right. All right. So this happens. This is very common. So definitely pay attention to this example. Right. So again, we can look at it and we say, do we understand what it means? And maybe we can get some meaning out of it. You know, there's some meaning in there. Why? Because, well, I didn't just make it out of anywhere. I made it up because of meaning. But in fact, is this one called there's a split rule, the cut rule. Anyway, so let's just hack at there, right? I swear this one we can really just hack at. So we see first, we're going to later have a section of the course on parsing, because you may or may not have taken 2001 where you parse. And when we get more complicated structures like this, we have to make sure we can figure out what it means. All right, but here I put nice clean brackets in, right? So you look for if you don't know how to break this up, well, I put brackets in to make it easy, right? If I say 3 times 4 plus 7, right? You have to know that the brackets go here, right? Well, I don't want you to have to know that. So I put the brackets in, right? So it's brackets implies brackets. So that's what our goal is. We assume the left-hand side. And, right, so line 2, we're assuming the left-hand side. And line 10 is we prove the right-hand side. All right? So now we can go forwards or backwards, right? Forwards, we split the and, right? Backwards, we say, now what I need to prove is it implies, right? How do I prove it implies? You look in the paper table under implies, and it says deduction. So the way I'm going to prove is this. I mean, this is kind of your question. Why do we do deductions?
Yeah.
Yeah. So it's because I prove this deduction, and within this deduction, I need to prove this deduction. And how do I prove this deduction? Is by deduction, right? So now, right, what is my goal? To prove the right-hand side. And how am I going to do it? I'm going to do it by deduction, right? And so I assume the left-hand side. And so now I know a bunch of things. I know 3, and I know 4, and I know not gamma, right? And so then I can start, what can I do with those 3? Well, not gamma plugs into this with selective OR, right? If not gamma is true and the OR is true, then not beta better be true, right? And now not beta is true, so not alpha better be true, right? Everybody get that? That's colons, right? If alpha implies beta and beta is not true, then alpha is not true, right? Now we got down to alpha. Oh, and what did we want to prove? Oh, that was convenient. What we wanted to prove is not alpha. So we're done, right? Does that make sense? And somewhere I had a slide and I think I removed it. Suppose I want to say A and B gives me C, and I don't quite know how to prove this. So an easier statement that if I put this in an axiom, there's cases where you don't quite know what to do. So an equivalent statement is suppose A is true, right? If A is true, then B implies C. These two are equivalent, and it's more or less what we just proved up there, right? Here, I mean, here we're saying if we have this and we have this, then we have this, and we broke it down to if we assume this, I don't know, maybe it's not quite the same. Don't look at compare, but here's, I mean, this sort of stuff comes up where you have implies, right? Everybody can here. I mean, this would be a good question. Prove that these two are equivalent, right? Here, what are you doing? You're thinking, well, if I know both A and B, then I get C, right? So I assume A and B, I get C. Well, what's this? Well, I assume A, and I need to prove this. Well, how do I prove this? I assume B. Now, if you look at my stack, what have I done? I've assumed A and I assume B, right? So now I can get C, right? Does that make sense?